this computer. Yes, I'm gonna recording this right now. So later on, when I finish producing this video, then we can review this video. Okay. But this is a demo. You're gonna get a chance to practice a similar question in a second. Okay. So you see, so the question here is reduce the following rational expression to the lowest term. So basically we have this s squared minus 16, 4x adding 16, right? So first of all, you're gonna factor. So very important technique is factoring. You're gonna learn how to factor both top and bottom. On top is what we call a difference of two squares. Difference of two squares. So it's x squared minus 16. It's like x squared minus 4 squared, right? So we're gonna factor as x plus 4, x minus 4. So that's how we take care of the numerator. So x plus 4, x minus 4. On the bottom, right, we're gonna factor by GCF. So this is the top. On the bottom, we use this technique called factor by GCF. Means that GCF here will be 4, right? So factor out of 4 and times x plus 4. Now we get a 4 times x plus 4. Now from here, we're just gonna cancel the common factor, right? We're gonna cancel x plus 4. And we end up with x minus 4 over 4. Okay. Do you guys have any question about this?
No.
Nope, very good. Yes. So I'll let you guys try one of the question, right? So let's go back to this screen here. Now I want you guys, let me see. I guess I'll go over one of this, and I'll let you try this. Just do a quick, I will try this as well, and I'll let you try a similar one in a second. So, please, you. Yes. And this question, we got to factor the trinomial, right? Anybody have issue factoring a trinomial? Or I'm going to show you a method how to factor this trinomial. Okay, so let me show you. Here it is. Okay. So the top is a trinomial. Right? So we get an x squared adding 2x minus 35. Right? So basically, the method I'm going to show you guys is basically breaking down the first term here, which is x squared. So the only way to break down evenly will be x and x, right? And I draw the cross multiplication sign in the middle. And from there, you're going to factor the breakdown the minus 35, right? There's several ways to break down that. And the key thing is to get a middle term plus 2. So we'll do adding 7 minus 5. The reason why we do that particular combination, because this 2, you multiply this 2, you get 35. If you're adding those two numbers, 7 minus 5 gives us positive 2. Right, so this is basically, it's like a quick method to get to the factoring trinomial thing. And we can double check by cross multiplying, right? So plus 7 times x is 7x, minus 5 times x minus 5x. And that gives us positive 2x. And then this is the middle term, right? Confirm the middle term. So we cover the middle term right here. First term is here, and the last one is here. So all three terms being checked. So that means your proper factor will be x plus 7, x minus 5. Okay. And I want you guys to try the bottom one really quickly. Factor the denominator here. Using the method I just showed you guys.
You need to talk and sort it out. Communication is really important.
Ace plus 7, ace plus 5.
Yes, very good. Yes. Okay, good job. So will be x plus 7, x plus 5. So I guess nobody have issue with this, right? Okay, x plus 7, x plus 5. Okay, because you're gonna factor x squared as x times x, and then 35 will be 5 and 7, all positive. Because the middle one is 12, positive 12. And you cross multiply, you're gonna get plus 5x plus 7x, which is 12x. Positive 12x. So the first term, last term, and middle term all confirmed. So that means this is right factoring. So we cancel the common factor here. We cancel this. And the answer will be x minus 5, x plus 5. And then all your homework will look like this, right? Basically, this is from your homework. So I'm just using the homework questions to show you guys, how to tackle all these different kind of questions. So you guys can try, I guess, question 3. Okay. Try question 3 here. I'll give you a couple minutes. Try that. And then I will show you the solution, or anybody want to share the solution, feel free to do that. Also, you guys are gonna have a break at the 10:15. I plan to give you guys a 30 minutes break. So have a coffee or have some snack and then come back at 10:45. I'll make an announcement later as well. Okay, just like to know. So every day we're gonna have a similar routine, right? We're gonna have 1 hour 45 minutes of lecture, and then after that you take half an hour break, and after that you come back for another 1 hour 45 minutes of the lecture. Okay, finish yet?
Yes.
Okay, very good. Okay, so who just so do you want to share your answer? Did you finish already? Okay, no problem. I'll go over the solution, right? So this is the question right here. So basically, first thing you're gonna factor the top, right? And if factor top, we're gonna use factor by GCF. What will be the GCF here? Look like 3, right? So you factor out the 3. So it will be 9x squared remains, and it will be 16 over there. Okay. And the bottom, we're also gonna factor out the 3, right? GCF is 3. And then we're gonna get 3x squared, adding 11x, and minus 20. Okay. And on the top, again, this is what we call the difference of two squares. Okay, so we're gonna just factor that. Okay, so we're gonna factor by difference of two squares. Will be 9x squared minus 16 will be 3x squared. minus 4 squared. So it will be 3x adding 4, 3x minus 4. Okay, so we get that on top, 3x adding 4, 3x minus 4. Okay, on the bottom, we're going to factor the bottom as well. So it's a trinomial. So we're going to factor by the method I just showed you guys. Okay, so break down 3x squared, right? That's the only way to do that would be 3x and x. It's like decomposing 3x squared. Now we're going to break down minus 20, right? There's some options. I'm just going to showing you the correct ones. But that's in this case, it will be 120, right? 210, 4 times 5. 3 different possible combinations. Only one of them works. Will be 5 here minus 4. And then how do we check that? We're going to do 3x times 5. That's the positive 15x. We do cross multiplying. Minus 4 times x is minus 4x. And when you combine them, you're going to get 11x. You see, so middle term is being confirmed. Right, so middle terms here, confirmed. First term, confirmed. Last term, confirmed. Then we get the proper factoring. So the 3x minus 4, x plus 5. And that will be 3 times 3x minus 4, x plus 5. Okay. Then we're going to cancel this common factor, right? This is the common factor. Cancel that. Cancel the 3. The common factor. Eventually, we end up with 3x adding 4, x plus 5. That would be the simplified answer. Okay. Yep. So that's the question we have here. So do you guys have any question about this? Okay, so all your homework assignments, right? I already make it possible. I actually assigned all of this over last Friday. So everything is here. And then your midterm is based on all these questions from the homework assignments. And we are on this right here, chapter 4, 4.1 rational function. So basically, okay, so we have a Miss Thomas, okay, joining us. I think she, yes.
No,
You good?
I'm the morning coordinator. I'm not a student.
Yeah. Oh, yes, I know.
Okay.
Carissa, right? Carissa. Okay,
Yeah.
so you're gonna stay here. You're good.
I just come in and check in, make sure that you're not having any issues. I have other classes to check in on though.
Okay,
well.
okay, I
Yeah.
got it. This is the first day today, so I don't know the procedure. So, but thanks though. Thanks for coming by. Yeah.
Yeah, and then you have a new link for tomorrow that you already provided the students with and everything.
Yes. I'm gonna also send it to via the chat as well. I
Okay.
sent them an email last Friday, so they have access to my Zoom meeting link for tomorrow.
Okay. All right.
Okay. So yeah, so let's continue. So go back here, you're gonna see this. We did a couple of them right here. So it's gonna be, so we work on this, right? So if you work on let's say problem 4, and then I also modify settings. So if you guys want to try similar ones, right, you can just show me another, and it will show another similar questions. You see, then we can work on that together. Yeah. So for example, like this one, it's a similar version. So let's take a look at how we factor this. So we're going to learn how to factor two. This is question number 4. Right? Let's learn how to factor the difference of 2 cube. I mean the sum of the 2 cube. It could be a difference, but it could be a sum, right? So in this case, it's a sum. So let me share this screen right here. Okay. So go back here. I just So let me just clear the screen one more time. Okay. I'm gonna copy this question. And let's go back to that. You share here. Okay. So basically on the top we get the sum of the two cubes. The first one is x cubed, and then the other one is 3 cubed, right? Okay. On the bottom is the difference of two squares. And we know how to factor that. So in terms of adding 2 cubed, you're gonna do this, right? You take this and this becomes the first factor. And then in the second parentheses, you're gonna do squared x and then minus the product 3 and x into 3x, and then adding 3 squared, so you get 9. And that's how we factor the x cubed plus 27. Any question about this? Okay, so now on the bottom, we're just gonna factor this x plus 3, minus 3. Okay, now you cancel the x minus 3 here, cancel that. So the remaining is the answer, x squared minus 3x adding 9 over x minus 3. Okay, yeah, so that's basically how you tackle this type of questions. And I guess if you want to, you guys can try one of the questions, right? Try this one. I'm going to show you another. Try this one right here. I give you a couple minutes. Try that. So one more time, I'm gonna put a Zoom meeting link for tomorrow in our chat. Okay, so you guys, so starting tomorrow, right, until the end of the immersion section, we're gonna meet via the email the Zoom link I emailed to you last Friday, but I will make sure I do that one more time so you guys can keep it somewhere. Okay. So, link. I'm gonna stop share for a second. Just gonna post the link to everybody in our chat. Zoom meeting meet. For tomorrow. And the rest of the learning section. Okay. Yep, so you should see posted in our chat. And we can go back to the question. Do you finish yet? So I guess I will go over the solution in this case. Okay. So go back here. One more time is a sum of 2 cube, right? It's an x cube. 64 is 4 cube. On the bottom is a difference of 2 squares. X squared minus 4 squared. On the top, as I mentioned earlier, right, so you're gonna do, you take the x and 4, that becomes the first factor. Second factor, you're gonna do squared x, and then the middle side always minus, right? That's the thing. And then you multiply x and 4, you get 4x. Third term will be 4 squared, that's gonna be 16. And that's how you typically factor the sum of difference. If it's a difference, I'll show you the difference in a second, right? But this is the sum. So the first side here is the positive, and this is minus. So that's a very important thing to remember is this one is positive, this one is minus. On the bottom will be x plus 4, x minus 4. Now from here, we're just going to cancel the common factor, this. So again, in factoring, the purpose of factoring is to cancel, right? Cancel the common factor. And so this is the most important thing we do in order to simplify the rational expression, right? This rational expression we talked about. So it will be x squared minus 4x, adding 16 on the top. On the bottom, it's x minus 4. Okay. Any question about this? We can put in the answers here, right? So on the side, you see this is the webwork, and then you can create a fraction. On top will be x squared, right, minus 4x, adding 16. On the bottom will be x minus 4, right? And you can just
x plus 4, x minus 4 for the top.
yeah,
And then
X
x minus 4 equal x plus 4.
x minus 4. Yes, we cancel the x plus 4, remember? Going
Yes.
back here, you see x plus 4 is canceled. Right here. So only x minus 4 left,
Yes.
right?
Yes, got it.
Okay, very good. Let's try that. Then you can check the answer, right? And once you check the answer, it will give you the feedback. If you get a correct answer, right, it will show you it's correct. Okay, right here. If let's say you messed up the sign, let's say you put in plus 4x, right? And then you check the answer, you will show it's incorrect, right? You're gonna see the answer preview here, see? And then, yeah, that's how you double check, make sure it's correct answers. Yeah. And also, if let's say you don't know how to input x squared, right? How do you get that? Let me quickly show you. Go back here, you see, that's the exponent. Click on that. So you put x first, then exponent, then put a 2. Okay, that's how you usually get the x squared. And then that's a shortcut, right? You want to get the x squared directly from the keyboard, you're going to do shift and 6. You're going to get exponent on the keyboard, x squared. All right. Any question about this?
No.
Okay, very good. Let's go back and then let's see anything else, you know. And this is a very similar one we did it. So I'll leave it to you guys for homework practice. And this is also very similar to the one we did earlier. And you guys can also try this on your own. Not a problem. I think you should be able to do this. It's good. And yeah, let's try this one. Okay. And this is kind of like, let me use a show me another. So we get a rational function here, g of x equals x plus 1 over x minus 6. And from here, we're going to do a substitution, right? Basically, we just substitute all the x values with the given numbers. That's what we try to do here. Let me share the screen. There we go. Okay, so we get a g of x. It's equal to x plus 1 over x minus 6. Now, first one, we're going to do g1, right? G of 1, meaning x becomes 1. So right here, replace x with a 1. So it's 1 plus 1 on the top and a 1 minus 6 on the bottom. So it'll be 2 over negative 5. And usually we rearrange it as minus 2 over 5. Okay. And g of negative 1. Okay. And similarly, right, replace x now becomes negative 1. So whenever you see x here, right, this x here becomes negative 1. X here becomes negative 1. So negative 1 adding 1. On the top, on the bottom will be negative 1 minus 6. So it'll be 0 over negative 7. What is 0 over negative 7?
Undefined.
If it is
Oh no,
negative
negative 7. I'm
over
sorry.
0, right? But it's very good point. Negative 7 over 0 is undefined. Very good. And here we have a 0 over negative 7, that would be 0, right? But you bring up a very good point. It's undefined. When that is undefined, and this is very useful tip. Moving forward, if you're taking the pre-calculus and calculus, and this is very important, like property we utilize to figure out domain, a lot of things. It's figure out where the function is undefined. Okay, but in this case, it's with 0. And g of 6, I want you guys to try this yourself really quickly. Finish this, try g of negative 6. Okay, so g of 6 will be 6 plus 1 on top, and the bottom will be 6 minus 6. I get 7 over 0, right? Will
Yes.
that be
Undefined.
undefined, right? And then they want you to enter as DNE, meaning DNE means does not exist. Very good. And g of negative 6, so negative 6, and 1 over negative 6 minus 6. And minus 6 adding 1 is minus 5. On the bottom, minus 6 is minus 12. That would be 5 over 12. Okay. So that's how we handle this type of question. G of 1, you can just put in the answers. Will be, you just did it, right? 2 over negative 2 over 5. By 5, yeah. G of negative 1 will be 0. And G of 6, that's undefined, right? Which is DNE, does not exist. And last one, negative 6 will be 5 over 12. Okay. And then we can check the answers. All right. Yeah. So so you guys can finish the rest of the questions on your own. It's not only 3 more questions left. Yeah, state the domain. Okay, let's try this one as well. Okay. What do you think? So this is a rational function, right? And the rational function, the domain is all real numbers except whatever number makes the function undefined. What number will make the function undefined?
Anything over 0?
Exactly, right? If the denominator is 0, right? That will make it undefined. So we're gonna dig out a point where the denominator is 0. So you're gonna set denominator equals 0, x minus 4. Well, and so that will give us x is equal to 4, right? Meaning this is the number which makes the function undefined. So typically, so the original domain is all real numbers, right? From negative infinity to infinity. Now we're gonna dig out a point. In this case, the point we dig out is 4, right? Right here, 4. So you're gonna put a circle here, meaning this number 4 is not allowed. So the domain will be this, right? This first piece and then second piece. The domain will be written as negative infinity to 4 union 4 to infinity. And we are putting the open parentheses for 4 because we're not including the 4, right? So that's how we find out the domain for the rational function. Okay. The domain of for rational function is all real numbers except whatever number give us 0 in the denominator. Domain for the rational function. It's all real numbers except whatever number give us 0, right? Whatever number give us 0. Okay, that's how you find out the domain for the rational function. Okay, and put it back, the answers will be negative infinity. So you're gonna type minus. You can also get this right from here. See, infinity, comma 4, close parentheses. You're gonna get a big capital letter U, right? Union means union. Or you can get it here, right? As you can see on the keypad here, that's a U. Okay. And also 4 to infinity. Also get infinity here. Okay. Close parentheses. And that's yeah, so you submit the answer here. Okay. And it's correct. Okay. All right. Yep, so I will leave the rest of this to you guys. You know how to do this. Okay. Yeah. So any questions about this? Okay, now we're gonna move on to next section, section 4.2. We're gonna talk about the division of the polynomials. Let's go to homework set 4.2. Polynomial division, right? We try to divide in the polynomials here. Now, first of all, let's start with the simple ones, right? Like this one. I'm gonna use show me another screen. So yeah, let's copy the question and let me share the screen. There we go. Okay. Now, first of all, if you have single term in the denominator, so what we can do is we can just split up. We can do ax to 5 over x cubed, adding 10x cubed over x cubed, right? Split up and minus 6x over x cubed. From there, you're going to divide 1 by 1, right? So a over 4, a by 4 is 2, x of 5 over x cubed is x squared. Take the first one. Second one, 10 over 4, you can reduce it, right? In this case, we can only reduce it. And then we drop we're just going to drop the x cubed here, right? That's a cube canceled. And then 10 and 4 we can reduce by 2, so it's 5 over 2. Yeah. And the last term, again, x going to x cube becomes x squared here, right? So cancel that. And then both 6 and 4 you reduce by 2, 3 over 2x squared. This one becomes 2 when you reduce it. Yeah, so that's basically how you simplify this. Okay. Do you have any question about this? Okay. Now we're gonna get to some of the more sophisticated ones, which is you're gonna maybe you guys try this really quickly. I'll give you a couple minutes, try this. Do you guys finish yet? Okay.
Not yet.
Not yet. No problem. Take your time. Yeah. Okay. Okay. So while you guys doing this, I'm gonna call attendance. So starting tomorrow, right? I will call attendance a couple of times. One is in the first half of the lecture, and then the other one is for second half. Okay. Share the, so let me go back to the log into attendance sheet. And I'm not gonna call attendance. Let me sign to the attendance sheet. Give me 1 second. Start from attendance. Hi, are you here? Hi. Okay, you know what? I'm just gonna see if I can. Okay, maybe she's not here. She's not here. And Abra. Yeah, Abra is here.
Yes.
Okay. Amaya. Amaya is here. Michael is here, right? Yeah.
Yes.
Okay. The meal job.
Here.
Okay, very good. And then Daniel is here. Okay. Septimonia. Septimonia.
Here.
Okay, very good. And Sita.
Yeah, I am here.
Okay, very good. And you guys know that, right? You cannot absent for more than, I think it's 2 days, right? That's the limit. And otherwise they will kick you out of the program. Ivan.
Here.
Okay, very good. And then,
Excuse me, sorry, did you say my name?
yes, Daniel, I got you. Yes.
Ah, okay.
Okay, I say your name. Yes. And then Pam.
Yes, here.
Okay, very good. And Carl.
Yes, I'm here.
Okay, very good. If I mispronounce your name, let me know, right? I will
Problem, no problem.
correct
Yes,
it.
yes.
Very good. Victoria. Victoria, are you here?
Yes.
Okay, very good. And then Lisha, are you here? Lisha. Okay, she's not here. Yep. And then Guang Yu. You're here, right?
Yeah, I'm here. Yeah.
Okay, very good. Okay, so I mark your attendance. I will, so I'm supposed to call attendance twice. But just want to make sure everybody's here. Okay. And then let's go back to the question we have. Somebody have a question? Yes. That's right. Okay.
Hi.
Johan, right?
Have you said my name yet?
Okay. Let me see. What's your last right? First name, that's right. Yeah, I don't see. Oh,
didn't
yeah,
Yeah,
I see.
Professor, I'm here.
Okay, yes, I see. Because they mark you, see, you missed 3 days. So, did you talk to the office about this?
No, what they first confirm I'm get the course, but they didn't give me the link. Then I mail you, but they didn't respond it. Then 3 days, almost 2 days later, they give me the link. That's why I have today absent first 2 days.
The 3 days, you see, on day 4, you also absent.
Yeah, those days I cannot join the Zoom link. I also mail my professor. I was like trying like almost 30 minutes, more than 30 minutes.
Okay, you should talk to the office.
Okay.
After class, talk to the office people, right? Send an email, tell them, you know, what happened to your attendance duration. So, yes, so I'm gonna share this with today's to. I'm gonna put you in for now, but you still gotta clear that with the office.
Okay.
Yes, that's okay. Yes, so
Thank you.
that's sure, no problem. Yeah, so let's continue, right? Let's finish
Yeah.
there. Okay, and then we are here. Okay, so first of all, you're gonna split up, right? So you're gonna split up as y cubed over y squared. On the bottom is minus y squared y. And that's first term. Second term, 2 negative will turn into positive. So it becomes positive. So you get 12x squared y cubed over 4x squared y. And the third one, same thing. 2 negative, negative, negative become positive. Okay, so ax cubed y cubed over 4x squared y. Now from there, we're going to simplify. So this is plus minus minus. 4 get cancelled. Cancel 4. X cubed over x squared is x on top, right? And y squared over y is 1. So it's minus xy. That's virtue. Second term, we get 12 by 4. We get 3, right? 3 remains. X squared over x squared is cancelled. Y cubed over y is y squared. So we get plus 3y squared. Third term, a by 4, that's 2. X cubed by x squared is x, so 2x. Y cubed by y squared. So this is our answer. Okay. Any question about this? Okay, then let's go back. Continue what we have here. All right, so let's move on to next question, which is a little bit more sophisticated. Yes, like this one, right? So I'm going to show you. This one could be dividing by factoring. So I guess not. You can do this yourself, right? So you factor the top, become x minus 8, and then x plus 4, and then cancel x minus 8. I want to show you a little bit more sophisticated one, like this one. It's when you cannot factor. Yeah, so let's look at this one. Let's learn how to do this step by step. Okay. Now let's go back here. Let's share the screen with you here. Yes. Okay, so first of all, we get x squared minus 6x minus 11. So you're going to write it as long division, just like how you will divide the numbers, right? These long divisions work a lot like dividing the numbers. Remember, let's say there's something like 534, right? And then you're going to divide, let's say, 7 into 534. What would you do? You take 7 going to 5, that's not enough. So you're going to do 7 going to 53. That's like 7 times, right? 7 times 7, and get 49, put it on the bottom. Let's subtract it. Okay, 4, and bring down another 4, right? So 7 going to 44, that would be 6. 6 times 7, 42. And then we subtract it, 2 is the remainder, right? You're going to write as 534 by 7 is 76, remainder 2 over divided by 7. It works very similar when we divided rational expressions, right? So you're gonna do this. So first of all, we take 2 terms, and then basically using the leading term here, x squared, by the leading term here, x squared by x, you get x, right? And they put it on top of the second term. Now next step, right? We get the quotient first, and then you're gonna do x times x minus 8. So x times x is x squared. X times negative 8 is minus 8x. Now you're going to copy that, put it underneath, right? So copy this. Now you're going to do this, put in the parentheses, x squared minus 8x. Yeah, we put in the parentheses and then we do subtraction here. Just like the division, you see long division with the did here, right? Very similar process. So x squared can cancelled. And minus 6x, minus minus becomes plus. So it's like minus 6x adding ax. Ax minus 6x is 2x. So you get 2x here. Now we bring down the minus 11, right? Just like how we bring down the 4 here, exact same thing. And then you're gonna do 2x by x. So you can also do the prep work on the side, 2x by x, you get 2, right? So you're gonna put this positive 2. You're gonna put positive 2 on top of the negative 11. And then also you're gonna do 2 times x minus 8. 2 times x is 2x. 2 times negative 8 is minus 16. So this is 2x minus 16. Now same thing, we put the subtraction, just like subtraction here, minus 42, right? Exact same thing. So we cancel the 2x, and we get minus 11. 2 negative turn into positive, so minus minus become plus 16. So it's 16 minus 11, so 5. So remainder is 5. Okay, so the answer will be quotient is x plus 2, just like 76 is the quotient, right? You put in the front, x plus 2. And then the remainder is 5. So you put 5 on top over divisor x minus 8. All right, that's how you handle this type of problem. Do you guys have any question about this?
No.
Okay, very good. So x plus 2, great. I'm glad you guys understand all of this very quickly. Very good. Yep, you can check the answer. Both correct. Okay. Now, let's look at next question. What if it gets a little bit more complicated? Can you do this? Okay, maybe I'll give you some time. Try this. Very similar, right? Just take longer, that's all. Okay, I'll let you try this. Do you finish yet? Okay, I give you a couple more minutes. This one is a long one. All right, so let's go over the solution. Okay, so we're gonna set up a long division, right? So first of all, you're gonna do this. So 3x cubed, adding 17x squared, adding 16x minus 21. And then put it, this is what we call a dividend, right? Dividend. The bottom is what we call the divisor. And then basically get a quotient and a remainder, right? This is what we call a quotient. And this is what we call a remainder. So we try to nail down all these different pieces one by one, right? I put it here. Remainder. So we just put a divisor on the bottom. So x plus 3 goes here. Ratios. Cause confusion. So step one, okay, I'll break down in detail steps. Step one, you're gonna take the two terms, right? We're gonna take these two terms because the divisor has two terms. Now you're gonna use a leading term here and leading here, using the leading term in a dividend over leading term on a divisor. So you do 3x cubed over x. Then once you simplify that, you get 3x squared. That means you're going to put that 3x squared on top of the 17x squared. So 3x squared goes here. All right. Now next up, right, you're going to multiply this, the term on the quotient, 3x squared multiplied by the divisor, which is x. Distributing, right? So you're going to get 3x cubed. Adding 9x. 3x squared times 3 is 9x squared. And then you're going to put that in the parentheses. And in 9x squared. And then subtract it, right? Very important. Remember, the key thing is to eliminate the leading term here, right? So this leading term must be canceled. If you cannot cancel the leading term, it means something's wrong. You're going to go back, check it. Now we keep going, so we get a 17x squared minus 9x squared. So continue from there, 17x squared minus x squared. So we get the ax squared positive, right? So we get ax squared as remainder. And we bring down another term, which is 16x. And we repeat the procedure, right? Repeat it again. Meaning you take the leading term here, which is ax squared. Then dividing by the leading term from the divisor, right? So step 2, taking ax squared by x, we get ax. I'm gonna put this ax on top of the 16x plus ax, positive. Okay. Now similarly, you're gonna multiply this ax by the divisor, ax times x plus 3. Ax times x is ax squared. Ax times 3 is 24x. Now we're gonna put this, copy this, put it underneath those two terms. And then put in the parentheses and subtract it. Just like how we would do it with the numbers, right? Exact same procedure, exact same method, but just a little bit more complicated, that's all. So ax squared, cancel ax squared, that's what we need to do, cancel that. I get 16x minus plus is minus. We get 16x minus 24x. Now we end up with minus ax, right? So again, minus ax here. Now bring down the minus 21. Now we're gonna get to the third step, right? Which is the final, because now the power are the same, meaning we get to the bottom of it. Third step, you're taking minus ax, right? Leading term here, dividing by the leading term from the divisor, x minus 8. That means you're gonna put minus 8 here on top of the minus 21. Now you multiply minus 8 by x plus 3. Distributed, you get minus ax minus 24. So we're gonna put that underneath minus ax minus 24. And then when you subtract it, right, minus ax minus minus become plus, they cancel each other. We get minus 21, adding 24. And that gives us 3. Okay, so the answer is 3 here. Remainder is 3. All right, so this is the quotient. That's the remainder, right? Quotient. Remainder is 3. So you're gonna put it as 3x squared, adding ax minus 8. 3 goes here. All right. Any question about this?
No.
No. Okay, very good. X squared. Oh, you guys are good. Yeah. 3x squared. Okay, and adding ax minus 8. And then let me copy the other to get the answers. Plus ax minus 8, the remainder 3. Okay, so go back here, and it's 3 here. Okay, now let's check it. Let's submit the answers. Yep, it's all good. Yeah. So this is important skills, right? By the time you get to the pre-calculus or calculus, we use this a lot. That's why you start preparing for those courses in the intermediate algebra. So you're gonna have a lot easier time. You pave the foundation for the upcoming courses. Okay, let's see what else is. Okay, this is another one. Let me see. Yeah, so I want to go over this one as well, because this one is quite similar. As you can see, it's similar to the one we just did. I guess you can, let me see. You can try it. Yeah, probably. Now let's try another, show me another version. You try the question like this one more time before we move on to the last question. Try this. I'll give you a couple minutes. Try it. Do you guys finish yet? Okay, I'll give you a couple more minutes. And the good thing is that if you know how to do all of this, then you'll be able to finish the homework with no problem because this comes directly from your homework, right? So it's sort of like you're preparing for the homework, and homework prepare you well for the midterm and finals. So that's how that works. So pay close attention in the class and then try to, learn as much as possible in the class. So you don't have to do extra like you don't have to do extra learning outside the class. That will help. Yes, let's go with the solution. So very similar, right? Like what we did earlier. And it's first of all set up as long division. Change the color. So we can do 3x cubed plus 26x squared minus 21x and add 8 as a dividend and divisor is x minus 1. Okay. Now step 1, right? You take the leading term. We're gonna use 2 terms here, but we're using the leading term 3x cubed. While the leading term on the divisor, which is 3x. And divide into that, you're gonna get x squared. And so we put x squared on top here. And then step 2, right? Next step, you multiply this term x squared by the divisor. X minus 1. It's really we're gonna get 3x cubed minus x squared. Minus 1x squared, you don't want to do that because we're gonna do the operation later, so it's better to put back the 1. So right here, I've put in the parentheses by the term 3x cubed minus 1x squared. And then minus, right? From there, you're going to cancel the leading term, right? Very important. Each term must be canceled. Otherwise, you did something wrong. Now we get 26x squared minus become plus 1x squared equals 27x. So we get 27x squared. Now next step, bring down the 21 minus 21x. Okay. Now very similar, right? It's like the another, repeat the process one more time. So we taking this leading term 27x squared, divide by the leading term, the divisor, x. Divide into that, we get 9x, right? And then you put 9x on top. It's positive. Positive 9x. On the top, now we're gonna do 9x, right? Times 3x minus 1. Okay, we distribute it. You get 27x squared minus 9x. So we have a 27x squared minus 9x subtracted. Okay. And let's see what we have, what we end up with. Again, we cancel this leading term, right? That's a key thing. Cancel the leading term. And minus 21x minus become plus at x. And combine them, we get minus 12x. Okay, almost there. Just one more step, right? Bring down the 8. Now repeat that process, right? One more time. So there's that. We taking the leading term here, minus 12x, over the leading term here, 3x. Simplify, you get minus 4. And that will be the last term, last constant, we get minus 4. Now multiply minus 4 by the divisor, 3x minus 1. Distribute it, get minus 12x, adding 4. Okay, and that will be this. 12x and subtract it, right? Don't forget it. We always subtracting those two parallel terms. Okay, so cancel this. I get plus 8 minus plus 4 is minus 4. So the final answer is going to be 8 minus 4, right? It will be 4. That's a remainder. And this is the quotient. So the answer will be x squared plus 9x minus 4. And we measure over divisor, and 4 over 3x minus 1. Any question about this? Okay, x squared. Copying. 9x minus 4, minus 4. Minus 4. Plus 9x. 4. And then on the top, it will be 4. And let's quickly check it. All right. And again, if you guys feel like you want to extra practice, right? You can just show me another. And you keep generating a similar question, but with the different numbers. So it's a very good practice. So you can see, you get a new one, right? And then you can, if let's say you are weak, you're not very confident about this topic, then you can practice some more questions here to get better at it. Now let's get to the last question in this section, which is question 7. And let's speak through that. I use show me another. So in this question, consider this polynomial, right? We call this third-degree polynomial function. Why is it called third degree? Anybody know? This is called third-degree polynomial function. Why is that? Any suggestion? Anybody know the answer?
Is it because it has 4 terms?
Yes, that's one thing, right? And then also another thing is, if you look at the leading term here, what's the leading term?
X power 3. So
Yes, exactly, right? This leading term determines this is what we call the leading term. Leading term is degree to the 3, right? That's why it's called third degree polynomial. Expression of polynomial function, right? Either one. And this is how we define all the polynomials, right? Let me give you another one. Let's say leading term xy adding y adding 1, right? And this will be 5th degree polynomial. That's how you distinguish different kind of like polynomial functions. And polynomial function is a very popular group of functions, you're going to study in pre-calculus and calculus. That's why we do so much practice, in these different topics to get ready for those courses. Now let's consider this polynomial, and what we try to do is, if x plus 2 is a factor, find the other 2 factors. So any suggestion of how we tackle this? What do you think? X plus 2 is a factor. we do long division, right? Basically, it's telling us this one divide into that, divide into the original polynomial, so we do x cubed and 5x squared minus 12x minus 36, right? So x plus 2 is a factor, means it's divisible into this, right? Just like 7 is a factor of, let's say 7 is a factor of 49, right? That means 7 going to 49, right? Very similar idea. That's how you apply to the polynomials. It works in a very similar way as the numbers, right? 7 is this factor of 49, right? 49 has three factors, 1, 7, and 49. And 7 going to 49. If x plus 2 is a factor, means x plus 2 going to this polynomial. Now we're going to apply the other, I guess. So that's 5, right? So we're going to do leading terms x cubed. So step 1, take leading term x cubed by x. And then we put it on top of this. And do x squared times the divisor. 2. Then distributing the x cubed and 2x squared. X cubed and 2x squared. Now we're going to subtract it. Now cancel the leading term. So we get 5x squared minus 2x squared is 3x squared. Bring down another term, right? And so we do x going to 3x squared. So we do 3x squared by x, we get 3x. Now go on top of this. And you do 3x times x is 3. 3x squared, adding 6x. 3x squared, adding 6x. Subtracted. Yep, so that's what we end up with, right? So cancel this 3x squared minus 12x minus 6x minus 18x. I'll bring down the last term, minus 36. Now, if you divide, so the third step, dividing minus 18x by, so it's minus 18. So it's minus 18 here. And do minus 18 times x plus 2. I'm going to get minus 18x minus 36. Minus 18x minus 36. As you can see, it's exactly the same thing, so you cancel that. You subtract same thing, they cancel each other, get 0. So basically we end up with this. And then that's a quotient, right? They want us to factor into two different factors. How would you do that? Any suggestions?
Would you use the same, so would you do like x plus 2 divided by
Very good. Yes, exactly, right? Like the one I showed you guys earlier would be greater than x squared, x times x, greater than negative 18 plus 6 minus 3. And you can only use the shortcut. It's kind of like a shortcut. If the leading term is 1. If the leading term is not 1, then shortcut doesn't work. Like if the leading term, the leading coefficient is 2 or 3, then this you're going to do the cross multiplication to get this. But here it works because the leading coefficient turn out to be 1. And then if you look at multiply this 2, you get minus 18. Right? You multiply x and x, you get square. When you add in them, you get either 3, which is middle term. So 2 factors is x minus 3, x plus 6. Right? So the least of those 2 factors will be the other 2 factors. Let me erase this. So I can put the answer here. And below here, those 2 factors is going to be 23 and then x plus 6. Okay. And that's basically how we will handle this kind of the questions. Do you guys have any question about this? Good. And then that's, I think is comma and x plus 6. Let's do it. Yeah, they're all good. We just need to put a comma in between. All right. I guess we're gonna take a break, right? We're gonna take a break until 10:45. You guys can have some snack or have coffee and then come back in 30 minutes. Okay. All right, I talk to you guys in 30 minutes.
So
Yep.
should
Question?
come at 4:45.
Yes, 10:45, right? Yes,
Okay,
let me
thank
make
you.
the announcement in our chat so everybody knows when we come back. Yeah, so please come back at 10:45. Okay, I talk to you guys in 30 minutes. Okay, at 10:45. continue the next topic, which is multiplying and dividing the rational expressions. So let's get to this. Let's start with the simple ones. Basically, when we try to multiply or dividing the rational expressions, we're gonna use the factoring, right? Most of the time, we're just gonna factor and then cancel the common factors on both top and bottom on numerator, denominator, and then we go from there. Okay, so let's take a look at one of these examples here. So the general principle is factoring first, and then canceling the common factors. And from there, we arrive at this final solution. Okay, so let's look at this, how we tackle this question right here. Okay. So share screen review. Here you go. So one of the questions looks similar to this, right? So basically on top and bottom, we see the difference of two squares. So general procedure of multiplying is simplified. The rational expression. Step one, factor as much as possible. Second step, cancel the common factor. Both top and bottom, on both numerator and denominator, cancel the common factors. Same thing, as much as possible. And then last step, just write final last step, right? In a simplified form. Write an answer. Simplified. So basically, right here, we factor the top. We can put everything in the parentheses. I feel like that's easier to follow. And there's a difference of two squares. It's x squared minus 6 squared. So x 6. That's minus 6 on top. On the denominator, the x plus 2, x minus 2. And then on the other side, it's x minus 2, and then x minus 6. And again, we're going to cancel the common factors. Here, x minus 2, that's common factor. One on top, one on the bottom. X minus 6, common factor. Cancel that. And whatever remains, right, that's solution. 6. That x minus 2. Okay, so that's basically just follow this 1, 3 first. Step 1, step 2, step 3. Then we get a final solution. Any question about this? Okay, so first of all, we get go back to the panel, get this fraction symbol, and then you can do x plus 6 on top, and then x plus 2 on the bottom. Check the answer. Yep, it's good. Then let's move on to, I'll let you guys try one of these, right? We use a assuming another option here. Okay, you guys can try this one. I'll give you a couple minutes, try this. Okay, so do you finish yet? All right, so I'll go over the solution. So first of all, we're gonna factor this. Right? This times the difference of two squares, so it becomes 7 minus 7. And the bottom, there's not much we can do, right? We leave as is. I'm gonna factor this one. X squared plus 13x, that is 40. One more time, break down, decompose x squared, or break down x squared. Break down 40 will be 5 and 8, all positive. When we add them, you get positive 13. Okay, so two factor will be x plus 5 plus 8. Okay, and similarly for the bottom, break down as x and x. And for minus 50, you use 7, 8, right? And then one of them must be positive. The bigger number is positive. The smaller number is minus, because when you sum up them, you should end up with the positive. So, and then we can also double check, right? Also always double check with the cross multiplying. Plus 8 times x is adding ax, minus 7 times x is minus 7x. And you combine them, and end up with plus x, which is the middle. And that's what we want. That's basically how we take care of this three terms. First term, last term, and middle term. Then we put it in the parentheses, x plus 8, and then x minus 7. Now from here, we're just going to cancel the common factors. This one is a common factor, cancel that. X plus 8 is gone, right? X minus 7 is gone. Okay, you're going to make sure one on top, one on the bottom. One on the numerator, one on the denominator. Once you cancel everything, you end up with X plus 7. Any question about this?
No.
Very good. So X plus 7. And that's the correct answer. And then we can double check. Should be good. It is good. Okay, so let's move on. And it's sometimes you're just dealing with the different factorings. You gotta apply different factoring skills, like the sum of the two cube. It could be a quadratic, right? Could be a trinomials. Could be difference of two squares. Different kind of technique we use. And this one is very okay. I see something different. This one is very similar, so we're gonna skip it. You guys can try it on later. Let's try something a little bit more challenging. Yeah, let's try this one. All right, you guys gonna try this one really quickly. No, actually this one, you generate. Yeah, let's try this one. It's good. Okay, I give it a couple minutes. All right, let's go over the solution. So anybody want to share your idea how to deal with this one? Okay, so first of all, put this right. You try to factor this trinomial here. Can we factor that?
Isn't it the same? So you could just cancel it out.
Exactly, right? So, and also we cannot factor this. It's not possible to factor that. So that's great. I just want to bring up that point. So why we cannot factor this? That's a way to quickly double check we cannot factor this. Is there any like idea how we can quickly know this
There's
is
no
not
perfect
factorable?
square.
Yeah, sure. I'm sorry.
That there's no perfect square.
Yes. Also, if you look at A here is 1, B here is 8, meaning the coefficient right in front of each term. C here is 40. If you do B squared minus 4AC, that'd be A squared minus 4 times 1 minus 8. That is 64 minus 160. Then it's minus 96. Since it's minus, that means there's no solution here. This is not factorable. That indicates it's not factorable. So it's better just cancel them, exactly. And that's how we do it. And then we also gonna factor the 5x minus 20, GCS 5 minus 4. Now we cancel this, right? Is answer 5 or 1 over 5?
5.
It's 5.
What can be considered
Sure.
the same though?
Is it 5 or 1 over 5?
1
So
over
this-
5.
Exactly, right? Very good. Because this one is a little bit tricky because once we cancel the top here, we actually could back the invisible one. So a lot of students make a mistake here when I teach this course, several years ago. So a lot of students forget to put 1 here and just write 5, right? Like 5 is not correct answer. When you cancel the term, that's invisible 1, it should be 1 over 5. That's correct answer. Okay, so this actually gives us some note, how to deal with this kind of problem. So the answer is just 1 over 5. And let's check it. Okay, it's good. All right. And let's look at some of the a little bit more challenging ones. Yes, with the division, right? We haven't talked about division yet, so let's talk about the division. So dividing, just like the fractions, when you divide the fractions, typically we turn into multiplication, right? So we do the same thing here. So let me quickly show you how we deal with that back in the algebra course, right? A over B, divide by C over D. And typically you carry over the A over B. And then turn division here in the middle to multiplication. Then I'm gonna flip the second fraction here. Or another way of saying this is the use a reciprocal. So reciprocal here is a D over C. Right, so, and then multiply across. So basically turn the division into multiplication by using the reciprocal of the second fraction to multiplication. Technically speaking, just for the second fraction, turn into a second fraction and into a reciprocal. Second fraction. Use this. And reciprocal is also a very useful term. We're going to keep seeing this, in the pre-calculus and calculus. This term is very, very useful, right? And also very, very widely used. moving forward to a lot of higher level courses. So just like what we did here, so you become 80 over BC. Just this is general guiding principle, right? Okay, similarly here, first of all, we're going to put in parentheses. Now we're going to turn this division here as multiplication. So carry over the first fraction, leave as is, and turn the division to multiplication, then use the reciprocal of this fraction here will become 5 over x minus 4. Okay. And here, sure, go ahead.
I'm sorry. Are you making notes right now?
Oh yeah, I forget to share. Yeah. Can you see the screen right now?
Yes. Yes.
Okay, sorry, I
you.
forget to share. Yes. So always, if you do not see the screen, means I forget to share. Immediately tell me so you don't lose any like work here. Yeah. Yeah. So basically, turn the division into multiplication. That's what I read earlier, and we flip the second fraction here. It becomes this, and then this is the guiding principle, right? When we learn basic algebras, we divide the fractions. That's how we do it. Now, next step, we're gonna cancel the common factor first because we see x minus 4 here, x minus 3. That is gone. And although we don't need to factor the denominator, right? We can leave as is. But what if we want to factor this? How do we do that? Any suggestion? This is what we call a perfect square, right? And this is a perfect square because we get this, we can transform a little bit. Or you can just factor that, right? X, and then bring down the 16 as -4, -4. Now you see this is a perfect square, right? Combine them and get -8. And this is like repeating factors. It's x minus 4 times x minus 3. That's why it's called perfect square. So you get 5 over x minus 4 squared. You can leave answer as 5 over x squared minus ax adding 16, right? No problem. That's equally good. But here I just want to show you this is actually what we call a perfect square. And sometimes you have to, most of the time you have to factor that because we can cancel the common factor. So it's useful technique. All right, so let's go back here and put in the answer will be 5 over okay, x. So if you want a perfect square here, you can open parentheses, right? X minus 4. And then click on this exponent and put 2. Okay, and then check the answers. Yeah, it's good. Also, you can just write the original denominator, right? Not a problem. You can just do x squared minus 3x. If you don't want to factor at all, it should be equally good for the system. Okay, you see, it's correct, but the equivalent to the one just submitted. Yes, but it's correct. Okay. Yeah. So, any question about this?
No.
No, very good. And I guess you guys are gonna try this one. This one has a heavy factoring. You gotta factor thoroughly first and go from there. Okay, you try it. Yeah, it's quickly, maybe let me just write down some of the factoring stuff, right? So let's say, just in case you forget how to factor factoring, reviews. First one is the difference of two squares. Of two squares. I just use A and B, right? A squared minus B squared. As soon as they are difference of two squares, will become A plus B, A minus B. And then that's the difference of two cubes. So something like A cubed minus B cubed. So you do this A plus A minus B, because the first term, the sign would always align with the first, so minus B, right? This is very, very important. This are aligned to this. And for the second factor will be A squared plus AB. Now this is plus B squared. The sum of the two cubes, the A cubed and B cubed. Now it will be A plus B, right? Same thing. So the side aligns. And then the middle one becomes the opposite square. If it is a perfect square, something like perfect square. Something like A squared minus 2AB plus B squared. It becomes A minus B perfect square. If it's A squared plus 2AB, you get side lines, right? B squared that will be A plus B squared. Yeah, just quick review all these basic skills. And you're going to use this a lot. In this course, in the pre-calculus and also in the calculus, any high level math courses, you always use all those basic skills. let's go over the solution. Okay, so first of all, we're gonna turn the division, right, into the multiplication first. So carry over the first term, first fraction. Fraction 95 on the bottom. Here, then flip it, right? Flip the second fraction, so x squared minus 13x. And it 40 goes first on top. And on the bottom, it's going to be x squared and ax and 7. Then you're going to factor forward, factor completely. So this one trinomial with x plus 4. Bottom is x plus 5. And the second one, this one is x 5 minus 8. And the bottom x plus 1 7. All right. Then from there, we just start canceling the common factors. Like x plus 1 get canceled, x minus 5 get canceled, and then whatever remains, right? That'll be the answer. So the remaining answer will be x plus 4, x minus 8 over 7. Okay, so that's the answer. Any question about this?
No.
No, very good. X plus 4. So let's first of all get a fraction. X plus 4, x minus 8 goes on top. On the bottom, it's x plus 7, x minus 8. Yes, 7 on the bottom. Let's check it. That's all good. Right. Let me see the last question, see anything. Yeah, so this one is it has a cube, right? So I let you try first. Yes, the difference of two squares, trinomial sum of two cubes, which is very good. So you get to practice everything. I give you some time to try this one on your own. Do you finish yet? Okay, give you a couple more minutes. This one is a little bit sophisticated. All right, let's go over the solution. So first of all, do we need to factor by GCF first? Or do we just factor that as difference of two squared directly? Factor by GCF. Anybody think about that? Or factor using the rules directly? Which way to go? So I'm going to write it first. Minus 4, and then 10x squared minus 4x 6. Now we turn the division here to the multiplication, 125 x cubed, adding 27 over ax cubed, adding 8. Yeah, so now here we're gonna make a decision, right? So for 4x squared minus 4, do we factor by GCF or factor using the difference of two squared directly? Any suggestion? Nope. Okay, so typically the general rule is that you should factor by GCF first, right? This always goes first. If the GCF it's possible, then you always factor by GCF. That will bring a lot of convenience later. So definitely we're gonna factor out the get x squared minus 1. And then that's still a difference of two squares. Then you apply the rules after factor by GCF. This is very important, you know, especially when the expression gets very complicated. This is always the rule number 1, right? Factor by GCF as much as possible. And similarly for the bottom, same thing, right? Factor out 2, you get 5x squared because every one of them are even first, minus 2x minus 3. Okay. Now for this side, on the second fraction, there's no GCF here, but we're gonna turn that as 5x cubed, right? Plus 3 cubed. Because we're gonna apply the that rule, the sum of the two cubed. But we're gonna make sure, you know, we know what those two numbers are. If we have an a cubed plus b cubed, will be a plus b, and a squared minus ab. But we need to know what is a, what is b, plus b squared. That's why it's easier to do the prep work first. On the bottom, we're gonna factor out the GCF 8. So it's x cubed plus 1. So this thing could get a little bit complicated, right? When the expression gets long expression, or it has several layers, then again you just tackle that one by one, factor by GCF, then go from there. And now that's just keep factoring, right? So on top it will become 4 x squared minus 1 is x plus 1, x minus 1. On the bottom, this is trinomial. So here, if you want to cancel this, you could do that, right? We cancel this 4 and 2 first. We can do that directly. 2 going to 4 2 times. Now you get simpler answers, and also 2 going to 8 4 times. Now we take it out of all numbers is gone, right? We only have 4 left here. Then on the bottom, it will be 5x and x. Wait on the first term, wait on the last term. 3 goes here, 1 goes here. One of them got to be negative. Will be this one, right? Because the middle term is minus 2x, so this one. And if you cross multiply, you get plus 3x minus 5x. That's minus 2x. That matches the middle term. First term, last term, middle term. So the factor will be this: 5x plus 3 and x minus 1. Okay. And then right here is the sum of 2 cube, right? So we apply this rule, and this becomes we go here. So it will be 5x plus 3. Okay, same side. And next thing will be a squared. So 5x squared. 5x squared is 25x squared. And minus AB, right? A is 5x, B is 3. Multiply them, you get 15x. And square root of 3, you get 9. Every 9. So we take care of the second one. And this one is slightly easier, right? We apply the same rule here. So, but it's slightly easier. So x plus 1, and it's x squared minus 1 times x. So it's just x, and then 1 squared is 1. Okay. Now, from there, we're just going to cancel as much as possible. Let's see, this one get canceled, right? X minus 1 get canceled. And then x plus 1 get canceled. I only have these 2 terms left. So the answer it's going to be 25 x squared minus 15x, adding 9 over x squared minus x. So that's how we put the final answer. Any question about this?
It's clear.
Okay, very good. So, okay, so let's put into this 25x squared. 26 here. Minus 15x. And then adding 9. That would take care of the numerator and the denominator. X squared minus x and 1. Yep. And let me ask you guys a quick question, right? This is the correct answer. No, it's incorrect. To go back. Did I? Minus 15x, 25x squared. Cancel that. No, actually, I cancel extra term. No, actually, it's all good. Yeah.
Mr. 4.
Maybe. Let me go back. 25x squared minus 15x adding 9.
You missed the 4.
Oh, Mr. Oh, yeah. That's right. Yes. Very good. It's right here. I forget that's a 4. We cancel that, but I forget to copy that 4. Right. Very good catch. Right here, 4. Oh, what's here? This four here. Okay, great. And going back here. Yeah, so goes down here. All right, that should do it. Yep, now it's good. And if you want to divide this, right, we can use the long division to divide this, but that's one way to do it. You can still divide this using the method we learned earlier, right, to turn into a quotient and then the remainder, but that's not needed here. And so you should keep answer like this for all the rational expression. All right, so this is basically the 4.3, and 4.4 is on the adding and subtracting the rational expression. Then that's everything on 4.3. Yeah, so let's look at adding and subtracting the rational expressions. So typically you're dealing, again, all of, that's a YouTube video here, you see, and one of the professors did record a YouTube video adding the rational expressions. But yeah, let's go over some of the questions here together. Adding, subtracting rational expressions. Start with this simple ones. So the general principle is factor first, right? And then find LCD, and we go from there. So let me just, first of all, let's copy the question. And we share the screen. Yep. So we add or subtract applies to both rational expressions. Step one, factor denominator as much as possible. As much. Or you can say factor completely. I think it's neater that way. You're going to factor completely first. And then we find the LCD. Find the LCD. And then turn both denominator into LCD. Then combine both fractions, right? And then simplify. And then turn both. Turn all of the denominators, or transform all the denominators into LCD. LCD, then combine and simplify. Combine and simplify as much as possible. And solve. Now we're going to follow this four step one by one. Going back here, first of all, let's back to the denominator here. First denominator. So it's like this, right? So you got A over B, adding C over D. And we know that LCD is B times D. Then you turn the first fraction as it's missing a D, right? We multiply D on both top and bottom. Second fraction is missing a B. So you multiply both top and bottom by B. And you get AB over BD. Adding BC over BD. Now they are the like fractions, right? So key thing is turning to the like fractions. Keep the like fraction denominator and then adding a numerator, BD plus BC. That's how you do it. If it's just numbers, right? Like regular fractions. And very similar with the rational expression. So we factor first, keeping the factor, both denominators. Factor by GCF first. Second fraction you're gonna factor by difference of two squares, x plus 6. Now, what's gonna be the LCD here? Any suggestion? It's slightly different from that, right? So, anybody have a suggestion? This question? Okay, no worries. So, 2, we're gonna need it, right? So basically, you're gonna need all the elements without repetitions. So 2 must be there, that x plus 6 must be there, both has it. Take one of them. Don't take both, right? Just one of them. What if one of them is like the, let's say hypothetically speaking, this is squared here. Are we using x plus 6 or x plus 6 squared? You use the, yeah, sure, go ahead. What do you think? Which one?
The whole square?
The bigger power, right? Always.
Yes.
Yes, so in this case, it'll be squared, but that's just hypothetically speaking. We don't have that. So here, if they are the same, just take either one of them. And then x minus 6. Now we get LCD. Very important. If you mess up this, then the remaining of the work will be off, right? So the key thing is to get a correct LCD and move forward. That's very, very important. Now you compare this to the LCD and look like this one is missing. You're gonna multiply both top and bottom by that term. X minus 6. That's x plus 7 on the top, x minus 6, right? Same thing. And then for the second one, the only thing missing compared to this is 2. So just multiply both top and bottom by 2, so 6. 6 times 2 on top, then x plus 6, x minus 6 times 3. Now they are the same denominator, right? Exact same. So we're gonna keep the same denominator, which is this. Okay. X plus 6, x minus 6. On the top, we're gonna simplify. So x plus 7, x minus 6, and adding 12, right? So we're gonna distribute it, FOIL this, combine like terms. I guess I will erase some of this. We don't need that anymore. So then combine, simplify, right? And that's final step. So once you distribute this, so we're gonna get x squared, adding 6x, adding 7x. It's basic algebra, right? Minus, no, actually minus 6x. All of the sign here. Because x times minus 6 is minus 6x. And then adding 7x minus 42, adding 12. Okay. And do it slowly, right? Sometimes if you rush, it makes a mistake. Like what I did earlier. So combine the like terms, combine those two like terms. So eventually we end up with x squared, adding x minus 30. Okay. On the bottom, it's going to be 2 times x plus 6, x minus 6. And do we stop here? What do you think? Or can we do something else? Is this the final answer? Reduce the expression to lowest term, right?
Yes.
So almost. And this one is a little bit tricky because after we combine them, we can still factor the top. You see, the top still factorable. Let's factor that, see what happens. It will be x plus 6, x minus 5. And once you keep factoring that. I guess I move out. Then we can cancel more. So this is the thing about the algebra, right? The requirement is you're gonna try as much as possible, and every step maybe something will change. So we create new nuances, and we're gonna tackle that along the way. So here, once we combine to this term, we notice it's factorable. And should try to factor that, see if that helps. And once we factor this, we notice that we can cancel another term. See, x plus 6 is common factor. Now actually we completely factor this, right? So it becomes x minus 5 over 2 times x minus 6. And that's actually what they mean by those terms. Any question about this? So adding, subtracting is slightly more complicated, but as you notice, compared to multiplying, dividing, so we just gotta be very careful about this. So x minus 5 on the top, 2 times x minus 6. Yep, so this is it. Yep, you see, if you put in the original answer, I'm gonna cut paste, then it will be partially correct. Earlier we get x squared and adding x minus 30. If you put in this answer, x plus 6, x minus 6, you probably will get partial credit. You will say, oh no, actually it's incorrect. So you have to factor completely, otherwise they wouldn't give you credit for this. Okay, so this is something I just want to show you, what happened if you forget to do the last step. You didn't get credit for this. So it has to be simplified to the lowest terms. So very important. Yep. So let's try another one. I want you to try that on your own. Try question 2. Let's see this one. Yes. So now this one is subtraction. Yeah, let's go back to this problem. I want you to try addition first, and then we will try subtraction. Yeah, you try this one. Give you a couple minutes, give a shot. All right, so let's go over the solution here. First of all, we'll factor the first fraction. Denominator factored by GCF. 2 goes out. Plus 8. And this one is a difference of 2 squares. So it's plus 8. 8. 8 on top. Right, so that's then use the LCD. It's gonna be 2 times x plus 8 x minus 8. And the first term is same this one. Okay. So multiply by x minus 8 of both top and bottom. Second one, we're missing 2. Okay, so 2 is missing. 2 is not there, so we multiply both top and bottom by 2. X plus 8 minus 8 times 2. Now, same denominator, right, which is LCD. Now, put them together into single one. Combine the like fraction. So we call this like fraction minus 8. On the top, we're going to get x plus 1, x plus 8, adding 16. 2 times 8 is 16. Then you're going to distribute the first 4 of the first term, first product here. So you're going to get x squared minus 8x, adding 9x, minus 72, adding 16. Bottom, carry over the denominator plus 8. Now, combine like terms, we make it x squared, adding x minus 16 minus 72, that is 56. So again, not done yet, right? Let's factor the numerator one more time. See if you can cancel the common factor. And this one turned out to be x adding 8 minus 7. So it is factorable. And once you factor that, then we do see another common factor here, cancel that. So again, 2 times x plus 8, x minus 8. And we cancel this common factor. And the final answer is going to be x minus 7 over 2 times x minus 8. So that's the final solution. Okay. Any question about this? So x minus 7 goes on top, 2 times x minus 8. And again, you have to simplify as much as possible. Otherwise, you will not get credit for the question. Okay. Now let's take a look at the subtraction. And subtraction is a lot like multiplication. The only thing is just subtracting, right? The middle sign is subtracting, that's all. No major difference. Factor both top and bottom. No, factor just the bottom, right? The top is not necessary most of the time. We're going to expand the combined like terms, see if we can simplify further later. But we usually don't. You can just keep the top as is. Just work on the bottom. Now here, just like typically you have a minus b, a over b minus c over b. Subtracting two fractions, and we know LCD is going to be b. Very similar. First one we multiply by b, a times b. Second one you multiply by b, c times b, right? Same common factor. Now we get the same denominator ED or LCD, and we get AD minus BC top. And we follow almost exact identical procedure top, we just carry over, not touch it, right? Carry over. Bottom, we're just gonna factor this. And it will be 7 and 6. And one of them gotta be negative. 6 is negative, 7 is positive. The other thing end up with positive. That means x plus 7, x minus 6. Minus 1 over. Now we can write down the LCD. Right, this term, both of the terms. So 7, x minus 6. All right, so now do the transformation. So first one, carry over, right? We don't have to do anything. Just carry over the whole thing because it's already LCD. So we just carry over. Second term, you're gonna multiply both top and bottom by x minus 6. 1 times x minus 6. Now, combine like terms, keep the denominator. So 2x plus 1 minus, it's really minus 1x. Minus 1 times minus 6 is adding 6 to that. Now, combine like terms with x plus 2x plus 1 minus 1x is x. 1 plus 6, 7. Now, one more time, we see that as a common factor, right? So we're gonna cancel that. Cancel this common factor, then the answer is x minus 6. But with the 1 on top, right? 1 over. But that's the invisible 1, put back that. 6. That's the answer. Okay. Any question about this?
Yeah, I got a question.
Mhm.
How come you're not doing like 2x plus 1 times x minus 6 and you're just keeping the 2x plus 1 there?
Because our LCD is this.
Yeah.
See? And this is already LCD. So
Okay.
we don't multiply anything here. So just simply copy the whole thing over. Or carry over the entire thing. And the reason why sometimes that happens, right? Happens to be the denominator happens to be the LCD, then there's nothing we have to do. We just carry over that from one step to another and go from there.
Copy that. Thank you.
Yeah, sure. And anybody else have a question? So the answer is 1 over fraction first, 1 over x minus 6. Let's do it. If you forget the parentheses on the denominator here, no problem, right? There's no confusion here. So yeah, you can just simply get rid of that parentheses. But usually, if you have more than one term, so you should have parentheses here. So let's say another term here, plus 7, right? Then you need the parentheses. Otherwise, the system will go back to wrong. Okay. Check the answer. It's good. All right. I guess I'd like to try a subtraction question here. Let's see. Sometimes you'll get a little more complicated. Yeah, you guys try this one. Okay. You get a factor both, right? Here, they're both factorable. All right, so let's go over the solution here. So first of all, we're gonna set the denominator here for x. So that will be, let's see, x and x. 80, 16 and 5, right? That'll be. And then one of them gotta be minus. This is minus. So it become x plus 16, x minus 5. First term, second term, this one. X, 3 and 5. The difference is 2, so minus 5 and 3. And it will be x adding 3 and 3. Now here, we're gonna look at the LCD. LCD will be, we take every single term here, so we do x plus 16. X plus 16 and x minus 5. Both of them has x minus 5 and x plus 3. So 3 different factors. That's LCD. Now for the first one, missing this one, right? You're going to multiply both top and bottom by x plus 3. Bottom, same thing. Multiply both top and bottom. And for the second one, minus, what's missing? This one, x plus 16. So you're going to multiply both top and bottom by x plus 16. Now, same denominator, OCD, TBS is that we're going to carry over the. So here we can just FOIL this separately and then combine them from there. So x is x minus 5, x. Then here to have 4x times x will be 4x squared. First term, second term, 3 times 4x will be 12x. 1 times x will be 1x. Positive. 1 times 3, it's 3. So take care of the first product, second product. So you put a whole thing in the parentheses. I guess I will put it in parentheses for now. So x times x, it's going to be x squared. Then x times 16. And that will be for x times 16, 16x. And then 3 times x, 3x. And 3 times 16 is 48. And again, combine like terms, equal like terms, like terms. And first term expanded with the 4x squared, get rid of the parentheses, 13x, adding 3. Second one, we combine them, everything become opposite, right? X squared, 19x, 48. You minus x squared, minus 19x, minus 48. And keep the bottom as is, just carry over that. 16 plus 5, and x minus x, no, x minus 5. Next. Now, 4x minus x squared gives us 3x squared. Yeah, I guess I'll put it on top so it's not too crowded here. Just gonna put those here. Okay. Continue from there, this one goes Yeah, so 3x squared, 13x minus 19x minus 6x, and 3 minus 48 is minus 45. And we don't usually stop here, right? We still get a factor a little bit more because the top is factorable. So first of all, factor by GCF 3 square minus 2x minus 16. Okay. On the bottom, carry over the whole thing. Up top, when you factor this three terms, it becomes times x minus 5, x plus 3. Over x plus 16, x minus 5, x plus 3. And you notice that we're going to cancel both terms, both factors that this factor and this factor, right? This one get canceled, this one get canceled. So eventually we just end up with 3 over x plus 16. So the follow-up step is very important to get the final answers. Any question about this?
Yes. When you took off the parentheses, I
Yeah.
noticed you have a 13 there. Shouldn't that be a 12? And if
13.
when you equal 4x plus 13x plus 3 minus x squared minus 19x minus 48.
Right.
How did you get that 13?
Oh, 13 is the 12 adding 12x adding 1x.
Okay, got me.
Combining, right?
I didn't see that. I'm
Okay,
sorry.
so no problem. 16. I'm glad you asked question because the process is it's very lengthy. Sometimes you lose track. So it's good, you keep up with every detail. And then also 19x come from this 16x and 3x. When combine them first, we get 19x, but it's subtracted. So then we still get to simplify further. And factor as much, once you combine like terms, factor more. Right, that's needed. And we notice that we cancel more terms after that. And get a final answer. Any other question? X plus 16. That's all we have. Yep, that's right. Let's check the answer. Okay. Let's check it, right? All right, it's good. Okay. So that's again in basic algebra, intermediate algebra, there's no shortcut, right? You just always gotta practice a little bit more. It's like you get enough training for this, then you become good at this. That's all you need to be successful in this course. And once you are very solid on these basic skills, you're gonna do well on the pre-calculus. If you do well in the pre-calculus, you'll do well in the calculus sequence, right? There's no doubt because it's built based on the previous course. All right, so now let's take a look at a slightly different one, right? At this one, adding the following rational expressions, reduce the expression to lowest terms. This one is slightly different from what we did earlier from the other questions, because the first one is not a fraction. And then how do we do it? Any suggestion? It's a whole number.
You turn it into a fraction?
Yeah, exactly. That's very good. So you're gonna turn into 2 over 1. Adding, right? Adding 9 over. 2x plus 3. Now then supply the LCD. LCD just 1 times that, so it's 2x plus 3. That's all, right? And then for the first term, you just multiply 1 by and 2x plus 3. Same thing, 2 times 2x. Oh, and the second term, carry over as is 2x plus 3. Now we both have LCD on the denominator, so carry over that, 2x plus 3. Now put it together, so 2 times 2x is 4x. 2 times 3 is 6. And adding. Okay, now combine the 4 numbers. So you get 4x adding 15. That's the first term. And that's it on top. On the bottom, it's just going to be 2x 3. And then there's no way to factor the top, right? You leave as is. So the answer is just 4x plus 15 over 2x plus 3. It's sort of like slightly different approach to this. But we still use LCD, no doubt. So 4x having 15 over 2x having 3. Okay. And check it. It's good. Let's see. Any other question? Yeah, you guys gonna try this one. Okay, try this one. It's subtraction, but almost the same, almost identical. Turn it as x over 1. Use LCD. Go from there. All right, let's go over the solution for this question here. As I mentioned, so we turn into a fraction first. So it becomes x over 1 minus 3 over 2x plus 3. And again, LCD is 2x plus 3. Then for the first fraction, we multiply both top and bottom by 3x plus 3. Second one, just simply carry over from previous step. And LCD, right? Able to your LCD is keep as is. Distributed, get 2x squared plus 3x minus 3. And that's all. Can we factor the top? Anybody try to factor the top? Is that doable?
No.
No, it's not, right? Very good. So we just keep as this. So this is the answer. 2x squared plus 3x minus 4 over 2x plus 3. So let's put in 2x squared plus 3x minus 4. Bottom is going to be 2x plus 3. That's all. Yep, it's good. Yeah, we haven't done anything with the three fractions. So let's see. This is last question here. I want you to try this one first. So basically, you're going to factor each one of these, right? Adding, subtracting. The sign remain as is, and use LCD. Combine the top, simplify. So I think you can try this one.
Muter.
Yeah, so sorry, I knew myself. So LCD, first of all, we factor the second term, and then third term, we get this. And LCD is going to be 2 times x times x plus 4. Yep. Then let's see what's we're going to put in the missing terms for each one of them. First one is missing 2x. We multiply 2x on both top and bottom. Second one is missing x. We multiply x on both top and bottom. Third one is missing 2. And so it will be 2, right? So multiply both top and bottom by 2 minus here. Yeah. So 14 times 2 x times x plus 4 times 2. So now we all have the same denominator, so it's gonna be 2x times x. And put everything together, we get 2x squared plus x minus 28. And do we stop here? So anytime you see a trinomial on top, you should always try to factor that, right? So we must stop here. Adding 4 minus 7 here. If the cross multiply, you get plus ax minus 7x x plus x, which is the middle term. First term, last term, middle term. So it's going to be 2x minus 7 times x plus 4 over 2x times x plus 4. Now here we cancel the common factor, that. So end up with 2x minus 7 over 2x. Any question about this? All right, so let's go back to the question and let's put in answers here. 2x plus 7 over 2x plus or minus 6. Yeah, minus 7. X minus 7 by 2x. And check the answer. Okay, any question about what we covered today?
Nope.
So, sure, go ahead.
It's clear, all clear.
Yeah, very good. Yeah, so actually, you know what? I'm gonna delete some of the assignments for you guys. I think maybe it will be too much for you guys to let me see. Is that too many problems? But definitely, right? You need to complete the. I guess I'll delete this. It's okay. So you can have less work and focus on the important things. So for you guys, you should definitely starting on this, right? Catch up on the homework assignments. And especially today, we went over this 4.1, 4.2, 4.3, and we almost finished 4.4, right? Adding and rational. We finished that actually. So your homework today will be 4.1, 4.2, 4.3, 4.4. Get it done by tomorrow, right? You can always revise it if you do not get 100% on those homework. Tomorrow we're going to continue on rational expression. I finished the chapter 4 rational expression tomorrow. Yeah. So any questions? So tomorrow we are using the new Zoom meeting link. Okay. So I will talk to you guys tomorrow then.
So the homework is 1 to 4, right?
Yes, 1 to 4, and then you already, Professor Allen forget to assign this homework, but you should do that. You should make up as much as possible. If you encounter some difficulty, right, let me know. We can maybe I can go over a couple questions, but I can't go over too many because we have a lot of lecture to do. We need to learn new content on a daily basis. I think the office does provide tutoring service, right? So you guys can use the tutoring service or get in touch with the office administrators. See if there's a tutoring service, so you guys can catch up if you need any refreshment on the previous knowledge. Okay, but I will see you guys tomorrow.
Question.
Sure, yeah, definitely.
Sorry, will midterms be next week?
Yes, midterm is gonna be July 16th, which is next week. Wednesday. So we're gonna review next week Tuesday, and then you will take the actual midterm. next week.
Mister, I have a question.
Sure, yeah.
Like, we gonna use this Zoom link tomorrow, or we gonna use the new one?
The new one. I sent it via the chat.
Yeah, but
Also-
what's the meeting ID and the password? We just use the link. That's really fine.
Yes, no meeting ID. You can click on it. I didn't set up
okay.
the meeting ID. You can just click on the Zoom meeting link.
All right, thank you.
Sure, no problem. Anybody else have a question? And if any question, before tomorrow, you can always email me. I usually check the email pretty frequently, and I'll get back.
Sir, I have some questions.
Sure.
Do we have the due for the homework?
Yes, all the homework is in the, I just show you, right? All the homework is in the web work. You see, today's homework is 4.1, 4.2, 4.1, 4.2, 4.3, 4.4, and we all the way up to the adding rational expressions today. So we did go over 4 sections today, and the previous homework, she forget to assign this homework, but you should do it though. You should catch up on you can catch up maybe every day, complete couple sections. So or if it's not too many questions, so if you can finish those as soon as possible, that'd be the best. Those supposed
Okay,
to
I get it.
Yes, I think Professor Daw is supposed to join us today, but for some reason she's not here. So maybe tomorrow, maybe he will join us tomorrow. Yeah, he did send me an email though, saying that he will, I guess maybe tomorrow. Yeah, I see you, Michael, and then DiMaggio, I see your chat. Yes, supposedly, right? Supposed to join us today. Maybe he has too many sections to join. Maybe he ran out of time. Hopefully he will join us tomorrow. Okay, and I'll talk about the midterm. Okay. All right, so I will talk to you guys tomorrow then. Okay, don't forget to do the homework, right? Okay.
Okay, thank you.
When I finish producing the video, I can email to you guys, or maybe I can share the YouTube link, right? When I finish producing the video. Okay. Talk to you guys tomorrow then. Bye-bye. Bye-bye, guys.
Bye bye. Thank you so much, sir.
Bye bye. Thank you so much.
Bye. No problem. See you.
Bye, thank you.
No problem. See you tomorrow.